How do scientists count the number of particles in matter? Well, atoms are present in huge, gigantic quantities, even in the smallest sample. And very often children think that big numbers are very difficult, but they're not. They're just big. How do we manage them? Let's look at the everyday examples we have. Here we have some eggs. If we go to the supermarket, we don't buy one egg at a time. We'll buy them in a box of 12. We call it a dozen. Similarly, when we buy donuts, we can buy them in a box of 12, though I don't recommend that very often. We could actually call that a dozen donuts. And it wouldn't matter what we bought. If we bought Dole biscuits, it would still be a dozen if we bought 12. Well, similarly, in this part of the lesson, we're going to learn about the chemistry equivalent, and we call that a mole. Chemists have a unit of measure that really easily manages those giant, vast numbers of atoms in a substance, and that's called a mole, the chemist's dozen. So, mole, the international standard unit for the amount of a substance, or the number of atoms in 12 grams of carbon-12, or 6.02 times 10 to the 23rd. You're going to hear that a lot. It might be something you put in your notes. Let's look at our examples. We start with a mole of sodium chloride. In our mole, there's 58.44 grams. And in that 58.44 grams, we have 6.02 times 10 to the 23rd formula units. Our water. In our 18.02 grams of water, 1 mole, we have 6.02 times 10 to the 23rd molecules. And finally, in the element magnesium, in 24.31 grams of magnesium, we have 6.02 times 10 to the 23 atoms, 10 to the 23rd atoms. Let's look at Avogadro's number a little more closely. There it is. It's also called Avogadro's constant. So if you hear that, it's just the same. And we know that it's the number of units in a mole, 6.02 times 10 to the 23rd. It was named after Italian scientist Amedeo Avogadro, and he proposed that equal volumes of gases would contain the same number of particles if they were at the same temperature and pressure. And what he did is he calculated this, determining the number of atoms in 12 grams of carbon-12. Remember that carbon-12 is the most common stable type of isotope in carbon. So let's look at the calculation he used. How to calculate Avogadro's number. 1 atom of carbon-12 has a mass of 12.00 atomic mass units, AMU. So how many atoms of carbon-12 are in 12 grams? We set up the calculation, and we have 12 grams of carbon-12. We know that's what we want to find out. We know that we have in 1 AMU, we have 1.66 times 10 to the negative 24th grams. We know that in 1 atom of carbon-12, we have 12 atomic mass units. So let's cancel out the units and solve the equation. We have grams and grams, and we have atomic mass units and atomic mass units. And what we end up with is 6.02 times 10 to the 23rd atoms of carbon-12. Molar mass and average atomic mass. What does that mean? Well, it's very easy to understand why we use moles as units. It's much easier to say 2.5 moles than it is to say, for instance, 1.51 times 10 to the 24th atoms. Huge numbers. But there's also another practical reason why we use the mole in chemistry. We use the mole in Avogadro's number to connect the average atomic mass unit and molar mass. Okay, what do I mean by that? Well, we know what the atomic mass unit looks like because we're given that information in the periodic table. And here it is. We have hydrogen at 1.01 atomic mass. We have carbon at 12.01 atomic mass. And we have oxygen at 16.00 atomic mass. The molar mass is the mass in grams of 1 mole of a substance. The mass in grams of 1 mole of a substance. Remember, we had that hydrogen, and it was exactly the same as the atomic mass, the grams. Remember, we had the magnesium. It was exactly the same in grams. The 1 mole was the same in grams as the atomic mass. What do I mean by that? Well, let's look at our oxygen. We know that oxygen is 16 AMU. We know that 6.02 times 10 to the 23rd atoms of oxygen is the same as 1 mole. And here we said 1 mole is the mass in grams. So it's 16 grams of oxygen. The very simple way of saying it, the molar mass of an element in grams per mole has the same value. They're the same. That's why we have the equal signs as the average atomic mass of the element in AMUs. The molar mass in grams has the same value as the atomic mass in AMUs. The mole is a really important unit in chemistry. We know, we've said that the mass of an element in grams is the same as the value of the atomic mass unit in atoms. So the periodic table can help us to work out the molar mass of an element. But in chemistry, most substances are compounds. What do we do about those? Let's find out. So how do we work out the molar mass of a compound? Okay, let's take an example. Let's look at sodium chloride. Where do we start? First thing, identify the component elements. So we take the sodium and the chloride, and we look at their, and we also take their average atomic masses. We know that we have sodium, and that's 22.99, and we have chlorine, and that's 35.45. Remembering we get this information from the periodic table. What do we do next? The next thing we do is we identify the number of atoms of each element in the unit. So we see that we have 1 sodium and 1 chlorine. Here it is, 1 sodium and 1 chlorine. What do we do next? We calculate. We do the maths. So we have 1 times 22.99, and we have 1 times 35.45. When we do the math, we see that we get 58.44 atomic mass units. All right. Next step, the final step, we convert from atomic mass units to grams per mole, and we said that they were equal. So we have 58.44 atomic mass units, which is equal to 58.44 grams per mole of sodium chloride. Now, what's next? What's the molar mass of calcium chloride? Okay, again, first step, identify those components and their atomic masses, their average atomic masses. So we start with calcium, and its atomic mass of 40.08. And again, we have chlorine, which is 35.45. What do we do next? How many? the number of atoms in each element of the unit. Here we see that we have calcium and chlorine again, but it's different because our subscript tells us we have 2 atoms of chlorine. So 1 atom of calcium and 2 there of chlorine. Okay, what's next? That's right, we do the math. So we had 1 of calcium, which was 40.08, and we had 2 of the chlorine. You know what, I'm going to put that in there so you can see. 2 chlorine equals 70.90. Together, they're 110.98. And the final step, that conversion from atomic mass units to grams per mole. We said that was equal. So 110 atomic mass units is the same as 110 grams per mole of calcium chloride, or 1 mole. Now, what about a compound with polyatomic units? Same process. Remember I said that sometimes to children big numbers seem more difficult? It's the same process. So we identify the component elements. We start with aluminium and its atomic mass unit of 26.98. We see that we have sulfur, and it has an atomic mass unit of 32.07. And finally, oxygen, which has an atomic mass unit of 16.00. What's next? We identify the numbers. How many? The numbers of atoms of each element. Again, we use our subscripts, and this time we use the parentheses to help us. We see that we have a subscript for aluminium of 2. That tells us there are 2 atoms. We see that in our sulfate, we have 1 atom of sulfur and 4 of oxygen. And we have 3 of those altogether of the sulfate. So we have 2 aluminium, 3 sulfur, and we have 4 times 3, or 12, of the oxygen. There it is. 2 times aluminium, 3 times sulfur, and 12 times oxygen. What's next? That's right, you guessed it. Let's do the math. So, in our aluminium, we have times 2. 2 times aluminium gives us 53.96. We have 3 sulfur, we said, and that gives us 96.21. I'm sorry, my 6 is missing. I do apologize. And finally, we have those 12 oxygen, and that gives us a total of 192.00. Add it all up, do the maths, and we come up with 342.17 AMU. Okay, final step. Convert the atomic mass units to grams per mole. Great. So 342, because remember we said they were equal, AMU is equal to grams per mole, 342.17 grams per mole of aluminium sulfate. Right. Now, let's go back and just run through it all one more time. How to calculate the molar mass of a compound. We identify the component elements and their average atomic masses, and we get that information from the periodic table. We identify the numbers, how many of each element in one molecule or unit. We use the chemical formula for that information. We calculate the mass of one molecule or formula unit. We do the maths. We simply add the average atomic masses and account for those subscripts when we're looking at the numbers of those atoms. We add them all together to get the total atomic mass unit. Then, finally, we convert from atomic mass units to grams per mole, remembering our molar mass in grams per mole is the same as, equal to, average atomic mass, and in average atomic mass in mass units.
If you know the molar mass of a compound, you can convert between sample mass and number of particles. Let's look at an example. How many formula units of calcium sulfate are in 15.255 grams? First, set up the unit conversion. We know that 1 mole of calcium sulfate is 136.15 grams, so let's multiply that by the 15.255 grams of calcium sulfate from the problem and by the number of formula units per mole. Then, cancel the like units and solve, remembering to use the correct number of significant figures. In this case, the given 15.255 has 5 significant figures, so the final answer should as well. Remember, molar mass is a constant value and doesn't impact the number of significant figures. So, grams cancel, moles cancel, and when we multiply the figures, we get 6.7451 times 10 to the 22nd formula units of calcium sulfate.
Let's do another one. The molar mass of water is 18.02 grams per mole. So what's the mass then of 8.21 times 10 to the 25 molecules of water? Set up the unit conversion. Same process. We have 8.21 times 10 to the 25th molecules of water. And we know that 1 mole is 6.02 times 10 to the 23rd molecules. We have the 18.02 grams of water per mole of water. 18.02 grams of water per mole. So, let's cancel the units and solve it. Here we have molecules, here we have molecules, here we have a mole, and here we have a mole. So what we need to do is the maths, remembering that those significant figures. And we come up with 2.46 times 10 to the 3rd of H2O, or water. So let's recap of how to convert between molar mass and number of particles. First, you set up the unit conversion. You use the molar mass to convert between mass and moles. You cancel the units and solve the equation. Make sure that your desired units, the units that you have left, are the only ones and that they're the ones that you want. If you've set up your conversion correctly, they will be the only ones you have left after you cancel.